If I've learned something in my career, it's that whatever your interests and skill sets and affinities are, there is a spot and a position and a value that you can add to this realm and this sort of work.
Welcome to another episode of Fascinated by Shipwrecks, where we delve into the people and the science of maritime archaeology. Today, I am joined by Dr. Art Trembanis, who is a professor of marine science at the University of Delaware, and I'm very excited to see what he's going to be telling us. So, Art, thank you so much for being here today.
Well, thank you, Kathy. It's delightful to be able to join you. Thank you so much for the invitation.
Great. So, you've got quite a varied background. So, I wondered if you could just let us know sort of how did you get started in the field that you're in? I mean, there's a lot going on with what you do. So, what did that look like, and what are you doing now?
Sure. Well, I guess I have been a bit of a wanderer in my career, and I think it kind of traces itself back to even being a young child, young kid growing up in the Pacific Northwest. I was surrounded by the waters of the Puget Sound and vacations and family time out at the coastline. And I have my roots are half Norwegian and half Greek, so there's kind of seafarers all around. So I was always sort of captivated by the sea. And I was inspired as a kid watching National Geographic on the weekends, and I was my hero was Dr. Bob Ballard. And there every week was you'd find the Titanic or the Bismarck or PT 109, and I think the combination of all those things, I thought, boy, it would be great if I could get to do something like that in my career. And I guess I'm one of those lucky ones who've throughout my career have managed to, in a non like linear pathway, it's a very circuitous route, managed to kind of get into those fields and happen to catch sort of the early wave of autonomous systems. And I think that's been a major sort of launching point for me. So it kind of goes back to that sort of early fascination and in terms, and so I guess, thinking the title of this podcast, Fascinated by Shipwrecks, I guess I've always been fascinated by shipwrecks, as many of us are. And I remember that as a kid, we would go out to the southwest coast of Washington State, and there was a shipwreck on the beach, the SS Catala. And you could walk around it, you could walk through it. I guess I had a kind of a tactile, that sort of experience at shipwrecks. I never really set out to make that a major part of my career. It's just kind of something that went from one to two to, oh gosh, there's quite a thread of shipwreck research as I look at things now.
Can you explain a little bit about the varied research interests that you do have, which include shipwrecks?
Yeah, it definitely includes shipwrecks. So by training and most fundamental sort of interest in research, I'm a geologist. I'm a coastal geologist and coastal physical oceanographer. So I'm really interested at the interplay between how physical processes, waves, storms, currents, how they interact to shape and mold the seafloor and coastlines and any structures around them. And so in order to do that, I have to use a combination of geophysical and physical sensor tools to measure things like waves, currents, winds, and then to understand the shape of the coastline and the seafloor. And we call the interplay of those two morphodynamics. It's this idea of morphology and the dynamics, the processes. And so shipwrecks are an object sort of on the seabed that then interrupt flow. And I kind of came to those sort of circuitously because I was studying how mines and objects on the seafloor are affected by waves and currents and how they scour. And so I didn't really necessarily think about shipwrecks per se, but then I had some colleagues who were working on the Queen Anne's Revenge Blackbeard shipwreck, and we saw some parallels in how we could understand scour processes to understand site formation. And so, largely my work is to try to utilize various technologies, platforms, and sensors to map and understand the coastline and the seafloor from shallow areas to deep parts of the ocean. And so along the way, we find that there's some insights and interplay to inform shipwreck understanding, for locating, characterizing, and then understanding shipwreck sites.
So that's one piece of it, right? And then you've got the robotics part of things, right?
Yeah, the all the robotic sort of thing, or somebody said, "Boy, you got all the toys or assets that we have," and I think that's born out of kind of two things. One, I guess I've always been a tinkerer, kind of interested in building and fashioning and making things. Whether as a kid it was making go-karts to go racing down the street or building forts, or in high school I got to build a device to sort of track plankton in the water column. And so that this sort of tinkering and that sort of DIY, do it yourself, this sort of maker revolution that we've seen in the last several decades. And I think marine sciences, ocean sciences, has always kind of out of necessity required that sort of ability to sort of make and design new things, because we're dealing with an incredibly challenging and harsh environment. Friends and colleagues who do space exploration, wonderful, amazing. I think candidly that maybe have it a little easier than we do in ocean exploration, because of the challenges of ocean pressure, corrosiveness of seawater. Seawater and electronics don't really play together so well. We've got organisms that can biofoul, that can try to chew on your sensors or swallow them whole. And so it's inherently a difficult environment to explore, which is why, here in 2024, we've really only recently reached, I believe, 25%, slightly north of 25% of the seafloor has been even mapped, in all of human history up until this point. So we're really entering right now, because of autonomous systems, drones in the air, underwater, autonomous underwater vehicles, remotely operated vehicles, autonomous surface vessels. It's like this whole alphabet soup of autonomous systems, robotic systems that are giving us a force multiplier in doing ocean exploration and mapping. They give us the ability to spend more time in the environment, go deeper in the environment more effectively and efficiently, and not in ways that I think there's a misconception that in some way autonomous or robotic system exploration is a eliminator of humans. It requires as many or more humans. It's really about sort of leveraging these technologies to improve our ability to go out, find and characterize, capture, and monitor sensitive sites, whether they're shipwrecks, sunken planes, maritime heritage from lost cities that have sunk below the waves, and any of these kinds of coral reefs. So these autonomous systems really are enabling technologies for us. And I was an early adopter of these initially for kind of my core interest in sort of seafloor morphology and understanding sediment transport processes. But I've always tried to look for and enjoyed those opportunities where we can take these technologies and approaches and transfer them into new and exciting challenges. And there's so many in the field of sort of shipwreck mapping and characterization.
Where do you see that kind of, maybe you could take just an example or two of where that technology is headed over the next, where you see it headed over the next 2 or 3 years? Like, I don't know what the trajectory is as far as new profiles for these kinds of machines. Like, how fast does that development take place?
Yeah, well, that's a great question. And I don't know that I have the magic crystal ball for the future, but I know what I've seen in my career in the last 24 so years that I've been working with autonomous systems. There's been an absolutely explosive growth and development of the systems, and we see more and more autonomous systems in more and more domains. I think the future is we're seeing kind of an increase in two principal areas in terms of an underwater exploration, and that is these very large long duration systems, primarily for defense applications, but also being used for oil and gas exploration. And oh, by the way, while you're going out and doing these other tests, you're going to find shipwrecks and things along the way. And so those are large systems that can go out for, maybe weeks, days to weeks to months, at a time, with the whole, basically they're like full submarines, but without the people inside. The other sort of area, so sort of the big things are getting bigger and going out there longer. Then there's quite a proliferation of smaller, lower cost, more accessible systems that maybe can't do as much or stay out as long, but that are really small and portable, and that are really, I think, expanding the user base, because inherently still it's expensive technologies, the platforms and the sensors. And so we're seeing a drawdown in the costs of the platforms, and I think we're also starting to see that emerge in the sensors, particularly an exciting area that I've seen and that we've been utilizing increasingly are what I call consumer sonar systems, or consumer fish finders. Basically, the kinds of sonar systems that people would put on a fishing boat or a recreational boat. These systems now have on them sophisticated, high resolution sonar systems that would have otherwise cost tens of thousands of dollars and really only belong to professional survey groups or institutions. Folks can go out and in shallow or coastal waters, and they can use these systems and make all sorts of discoveries. And so if I had to guess, I would say we're seeing an increase in across those two. Another thing is that I think we're going to see, and we're already starting to see some of this, is increasing uses of coordinated multi-autonomous systems, coordinated swarms of systems. So it's not just going out with an ROV or going out with an AUV. It's going out with drones, aerial drones, autonomous surface vessels, AUVs, ROVs, recognizing that each of those platforms has different strengths and the limitations, and each can be used in a different way. When I first came to the University of Delaware and set up the first AUV lab, I had an AUV. That was really the core of what we had. Well, everything was an AUV job because all I had was an AUV. If all you have in your tool set is a hammer, every job is a nail. And now what we're sort of seeing, and so the way I sort of approach it now is to challenge my students, or anytime we approach a new project, is to say, what are we trying to accomplish? What is the area we're trying to explore, or map, or understand? And then now let's look at the toolbox and think of what's going to be the best set of sensors and tools that are going to allow us to do that job, and then sort of piece together this Marvel superheroes sort of consortium, the Avengers, to sort of pull it off. And it's not just an Avengers team of the technology and the technologists, but we need the archaeologists and the historians and other scientists and team members to really help pull together these expeditions.
So that's kind of like it takes a village to go.
It absolutely takes a village, yes, to kind of run herd and chase around these robots in the wild. Yeah,
I find that really fascinating because it really is like a combination of people working together as a team to bring together all of their skills and abilities, as well as the technology to go out and do this kind of mapping work and investigative work. So how does, if you can give us an example or two, how does some of that technology play into what you're doing when you're looking for or working on a shipwreck site?
Sure. Yeah. So, for me, the most, exciting, I can look back on some amazing expeditions and things we've had over the years. And, and for me also, the most exciting one often is what the next one is going to be. Like we're talking right now, and half of my team is feverishly prepping to go to sea tomorrow to conduct some mapping of some artificial reef sites and to try to recover a lost instrument lander that's on the seabed. And in each of those cases, it's the the combination of team and technology and objectives is different, and that's part of the, I guess, what kind of helps sort of stave off senescence and just kind of keep things fresh and new and exciting, is that we can take some of the technologies. Every time is a little bit different. There, if I think back, there's some examples of ones that come to mind. The image behind me is from an expedition we did to Bikini Atoll, where we were asked and invited by the National Geographic and Drain the Oceans production team, together with Search Inc., to kind of come in and map the historical seascape from Operation Crossroads and nuclear testing in 1946, where they did the first underwater testing with the Baker blast, and they did a series of 2 atomic tests, Able and Baker, and tested sort of how these new nuclear weapons that had only been used 2 other times in theater of war, in Hiroshima and Nagasaki, what would they do to ships sort of arrayed, in a simulated battlefield. And we were able to come in. We were sort of tasked with, how are we going to go and map that? It was by far the farthest area we've ever had to sort of journey. So, immediately, what for me, some of the biggest challenges are the logistics. How are we going to get halfway around the world? It took us 7 days, 6.5 days to get there from the time we left. And it was several plane flights and a 4-day steam where we didn't see land or any planes or any other ships, until we got to Bikini Atoll. And then knowing that we would have to have everything with us to try to conduct our mapping, and in case there was any issues, sort of bring out some redundancies of systems. And oh, by the way, we've got a week to do this, whereas we easily could have spent a month or 2 there. And so we had to then come up with mobile sonar systems that we could quickly adapt and mount onto a vessel of opportunity that we didn't really get to see till, other than through pictures, until we showed up on site. So that's an example where we've got to take a small team. Normally I'd love to go with 6, 7, 8 folks. They said, well, you've got room for 3, and try to do all of that within those sort of constraints. And another expedition I'm reminded of is in the Aegean Sea. We had the opportunity to go and work out of the Institute for Nautical Archaeology aboard a sailing training ship, the STS Bodrum, and it was incredible. At one point, I sort of felt the hair stand up on my arms, because I realized we're on this replica of a sort of a 19th century sailing ship with 21st century robotic technology. We had to ship an AUV system over there with a team of high school students, undergraduates, graduate students, engineers, scientists, archaeologists, all living aboard this sailing ship, sailing out to an ancient Greek settlement site, Knidos, off the Dacia Peninsula, and then using these advanced technologies off of this sailing replica ship and finding 3rd century BC sort of shipwrecks. And it was as if, a time tunnel had been suddenly, connected across, space and time. And in any of these times, whether we're looking at an ancient shipwreck or something from modern theater of war, a shipwreck suddenly connects us to a moment in time, whether it's tragic or intentional. And it allows us to sort of try to again, for me, it's about trying to utilize these technologies to give a new insight and window into these systems. And particularly to try, my role is to try to use these technologies to help provide more insights to the maritime archaeologists, but also to recognize that it's through the lens and understanding of the physical and geological processes that we're going to understand how these sites not only are today, how they got to where they are today, and then where they're going, in the future. As we know, some ships are decaying. Are they going to release pollutants and expose chemicals or potential munitions? Are they going to be degraded in such a way, and these sort of come into then the discussions about how sites then potentially get managed. Do we go through a recovery effort? Do we leave them in place? Do we document them? It's in each case, it's a different sort of Rubik's Cube combination to kind of piece together, which I find always sort of challenging and fascinating. And we try to, adapt or overcome to get to the goal line.
Yeah. It's like a different operational profile for every time you have to do something like that. So, yeah. I can just imagine it, which is why we're talking about it, so that people who can't go and do what you do can get a little bit more understanding of what that's like. And it's not just like, like we might see on a documentary where you've arrived and you're doing this work. It's like you said, it took a long time to get to that location, and you're on a research vessel. You have to develop, good relationships with everybody on board, be in tight spaces, be able to assimilate the food, whatever else you need to do, like just as a human being doing that
Yes.
work. I imagine it can be grueling at times.
Grueling, exhausting, frustrating, or at times, many many long hours of not finding things. I know a lot of places where shipwrecks and other targets aren't, and then you get these punctuated by these sort of moments of just euphoria when you find something. I'm reminded of an expedition we did a few years back up in the Great Lakes. We were in Thunder Bay and Lake Huron, and we spent days and days mapping. We had, sometimes we'd go out and do these expeditions and we're looking for unknowns. Other times, when you're going out looking for you have a target in mind. Of course, there's a binary outcome in that. You either find it or you don't. And sometimes we don't. Oftentimes we don't. But I remember we spent days and days mowing the lawn back and forth, this sort of very laborious sort of task and going back and forth. And by the way, that's one of the ways in which robots are really great, because they don't get tired. They run those lines really well. But we were mowing the lawn back and forth, sort of going blind, staring at a computer screen that was coming, sort of seeing lots of interesting geology and seafloor and nothing and nothing and nothing. And then all of a sudden a scream erupts in the sonar lounge because they see something sticking up from the seabed that look, that doesn't look natural. And it turned out it turned out to be the wreck of what was called a whaleback steamship, the SS Choctaw. I'd never seen anything like it before. It was sticking like in the lake bed like a javelin that had, or a lawn dart, and because it had come to rest in this sort of area. And so you get sometimes these periods where nothing, and then another, and then oddly enough, within a few other hours, a few more turns, we found another shipwreck. So sometimes it can be, quite quiet, and you just have to sort of know that those long hours and be prepared to do those. And again, mentioning that sort of village, that village requires a diversity of folks, a diversity of talents, backgrounds, perspectives. And so, I think if I've learned something in my career, it's that whatever your interests and skill sets and affinities are, there is a spot and a position and a value that you can add to this realm and this sort of work. Maybe you don't have the stomach for going out and being tossed around at sea. That's okay, but maybe you're really good at doing archival research, or helping to find the funds, or prep the equipment, or do the data processing, or we're using increasingly AI to locate and go through these large data sets. So across the spectrum of backgrounds, there is a world of opportunities and a world of ways in which those skills can be brought to bear in this field.
That's great, because it's, I guess some of us, and I could be, sort of misunderstand this myself, but it's like it always feels like they're out there and we're just watching. But like, as we've been learning on the podcast about citizen science, even people who are not professionals can get involved, like you say, bring their
Absolutely.
own skills and their own interests and abilities to projects like that. So like, I know that you work with your students. Maybe you want to say a little bit more about what it's like to be teaching marine science.
Yeah, I mean, that's one of the great joys that I have, is being able to bring the stories and the lessons and the data from the field into the classroom for my students, but then also looking for those opportunities where we can bring them into the field, whether it's an at-sea expedition, or field experiences, field trips, study abroad travels. I'm getting ready in January to take 25 students to New Zealand for 3 weeks, where we're going to explore along the coastline and just experience another part of the world and history and cultures and the environment. And so, for me, it's very much a paying back. By paying forward, I'm sort of paying back for the mentors and the instructors and teachers who did that for me. And the thing is that there's this sort of textual or sort of the content sort of knowledge that we try to impart, but a big part of it is just trying to help students to become learners for life, and knowing that many of the technologies and skills that we're using today weren't in the textbooks. They weren't in the class curriculum when I was a grad student or an undergraduate and stuff. And so I'm always sort of forced to kind of stay youthful, I guess, in the sense that I've got to try to keep up with these emerging technologies and techniques, things like virtual reality and augmented reality, where we're now taking our maps and making them available to folks, AI and machine learning for, again, data processing and interpreting what we're doing. And so I work then with students that might be traditional marine science students or computer science or engineering or robotics or, different sort of backgrounds. And in each case, there's both a combination of hard and soft skills that have to be learned. How to work together with the team, how to tie knots, how to be out at sea on a boat and avoid falling overboard or losing any of the expensive equipment. Then the students graduate and we bring on a new set and we start the whole process over again. And it's each time, again, just like our expeditions, it's a slightly different cohort, and it's a new things that we need to try to convey to them, and so that I like those challenges, and I enjoy seeing then places, especially if I go back to a site or a field location, introduce a new technology that may not be new to me. I get to experience those again through the eyes and the experiences of those students and or community members in when we do sort of outreach activities as well. And I think that's an important, I think we're duty bound for that. I think for those of us who get the opportunity to be out there, that we know that we're on the top of a scaffolding of the pyramid and mountain of folks and efforts and things that have gotten us there. And so I think we are duty bound to share those stories, share those insights and those techniques and technologies. I remember kind of a grizzled old marine operations technician told me years ago, he said, well, got to teach them well because someday you might work for them. So I try to keep that in mind.
Yes. Okay, well, unfortunately, I have to stop this episode right now. I would love to continue this, but I'm sure we will be speaking again. For now, I'd just like to thank you again so much, Art, for being here today, and this has been really fascinating.
Thank you, Kathy.
Lost in time, the wreckage lies, broken masts and shattered pride. In the deep the answers hide, echoes of the past call out, whispers from beneath the waves. What secrets do the shadows keep? Do we dare disturb their sleep?